Thanks. I'm going to have to give you my wife's telephone number. It's really great to be here today. I must say I found it an exciting day, as I have found association with UK Biobank over the last several years. So I want to talk to you about the imaging enhancement, which is a tremendously ambitious enhancement, really, I would say, out of completely establishing a new scale of ambition for epidemiology studies. It will evaluate 100,000 of the 500,000 individuals in Biobank over the next roughly six and a half years, with a comprehensive body and brain phenotype, including brain, cardiac, and body MRI, DEXA, and 3D carotid ultrasound. As you've heard from Barbara and John, it also offers an opportunity to allow a large number of participants to revisit for some additional general phenotyping. But what is exciting about imaging is that it has not only does it provide an extraordinarily rich kind of data set, but it also has a salience in the public imagination that I think really helps to bring the impact of this kind of large study home. In commenting on the Human Connectome project in the US, a paltry study of only several thousand, James Gorman of the New York Times noted that he was excited about this, being a participant looking for a hint of his own individuality. Well, what is the scientific value, though? That's what we're really concerned about. Imaging extends a description of the phenotype. It is just, the methods are just tools, but they help us look into the living body and begin to understand organ systems in their in vivo environment and something about physiology. The images can be integrated with non-imaging data of the type that we've been hearing about all today, to do something that really has never been done before, because the communities for imaging and the communities for epidemiology have traditionally been so far apart. The population size, even for the extension alone, is such that it's also going to allow associations between imaging and non-imaging phenotypes across a whole range of the disorders of late life, as well as helping, and this is what the imaging community still remains most interested about, helping us understand individual variation. Moreover, because of its prospective nature, of course, and what we hope is really the kickoff of serial imaging across the population, it allows an opportunity for real risk prediction in an image context because of the prospective nature of the studies. This is not only a hugely challenging enterprise, but it's also one that I think fills one with real optimism for the way science is changing and the way scientists are working together. Rory helped to pull together a UK and in fact a global imaging community in kicking this off and helping me see how exciting it was. That has all been facilitated by the UK coordinating team. Over the last 4 or 5 years, an expert multidisciplinary group from particularly the UK, but as I said, the world over, has been called in for very broad consultation. There has been input from multiple professional bodies, including particularly the Royal College of Radiologists and the Society and College of Radiographers. In doing this, not only are some of the practical details being addressed, but it's allowing the approaches that you're going to hear about very briefly in a minute to be done really at the cutting edge, to future-proof this resource so that when we continue to use it 10, 20, 30, 40 years from now, we're going to find that the imaging data still is of very high quality, representing what is currently state-of-the-art. And to do this, it's engaged people in pre-piloting efforts at universities across this country and abroad, and in working with the manufacturers, particularly including Siemens for the MRI systems, in trying to create really important solutions to what are otherwise somewhat vexing issues. Now, my hat as an imager remains firmly off, as you can see, for the way in which Biobank has approached this as a challenge in process development to try to take this very complex technology, integrate it into an examination that is tolerable, and do it all with an efficiency and on a scale that allows costs to be reduced to make this kind of large-scale concept feasible, and to ensure that it is tolerable by the subjects and that they will come back. Just to highlight what the kind of general thinking that's going on, the imaging will take place in purpose-built centers, really inexpensively constructed and specifically devoted to the challenge of imaging over the next 5 or 6 years. The first one is opened up at the Biobank site in Cheadle outside of Manchester. Subjects, when booked, report to the center where they're welcomed and prepared for movement through a series of stations by being clothed in what is effectively a hospital gown to eliminate concerns about metal and other potentially risky objects that might be carried in the region of the imaging systems. They then move between the phenotyping stations that you've heard about a little bit earlier, and the three scanning rooms. One, a 3 Tesla MRI scanner for the brain. 2, a 1.5 Tesla MRI scanner for cardiac and body imaging, and 3, a room with DEXA and 3D carotid ultrasound examinations. And as they move through here in a fashion that has been highly optimized via computer control of subject movement, they move towards being able to complete the examination in a very short period and out the door on their way. Meanwhile, some of the real hard work begins in the guts of the system. Again, huge work from the Biobank team as these massive data sets are pumped onto secure servers and through a QC process that I'll allude to a little bit later. And subsequently, there is review to manage incidental findings that may be reported, a point I'll come back to at the end. It's really exciting. Now, what comes out of this attention to process in order to achieve this very specific purpose is that rather than costing many hundreds of pounds per scan to create an extraordinarily expensive examination for 100,000 people, the cost per participant is estimated to be at about 350,000 if the current throughput targets are achieved, 350 pounds per subject if the current throughput targets are achieved. That's really extraordinary scientific value for the investment. Well, what's the progress update? Steve Garrett gave me data pretty much hot off the press in the last day. And the imaging started in the beginning of the pilot phase, moving very slowly to ramp up the rate at which subjects are moved through as lessons are learned to further optimize the process. It began on the 2nd of May, but they're already up as planned to 12 participants per day in 4 days per week, and tomorrow will mark the first 250 subjects that have complete data sets in the system. By August, it will be up to the final target we anticipate of 18 participants moving through each of 7 days per week. Despite this throughput, despite the apparent complexity of the process, what is even more remarkable to me and more exciting is that the feedback from participants thus far, although it's a limited number from whom this has been able, a limited number that we've still seen, the feedback is extremely positive. First, people who are being invited from the biobank cohort are responding favorably, with 37% of people who are first contacted agreeing for follow-up about this sub-study. After pre-screening for criteria for safe scanning, about 28% are able to be invited. And then more impressive to me than that is once the scanning appointments are made, really out of the first, this was about 2 weeks ago, out of the first roughly 150, there were only 3 no-shows and 7 postponed appointments. Overall, this is even now leading to an extraordinary use of the facility, which is really exciting. And people are leaving with a generally good view of the experience. Most have expressed willingness to come back again for a follow-up. Very few have reported claustrophobia in the MRI systems, where one has to go in a long tube, and a much smaller fraction have reported other dysphoric experiences because of the very loud Gatling gun-like sound that comes from these scanners. Let me tell you just a little bit about what the protocol involves, and I'm not going to go over it in great detail, although there is some detail on the screen. But what I want to just emphasize is the range of examinations that are being performed in extremely compact scanning protocols. Detailed structural scanning to tell us about tissue in the brain and its distribution. Functional magnetic resonance imaging scans looking at the basal activity of the brain at rest to understand slow oscillations across the brain, what the brain is doing when we're not thinking about anything in particular, and believe me, it is doing something. And then task fMRI, which is what happens when the brain becomes focused on a specific cognitive problem, in this case assessment, implicit assessment of emotional faces. Detailed and diffusion scanning is being performed. This allows one to map out the wiring diagram of the brain, at least on a mesoscopic scale, and is drawn from the experience of the US Human Connectome Project. Susceptibility weighted imaging that's sensitive to microbleeds, flare imaging, which is sensitive to changes associated with edema, demyelination, gliosis, such as accompanies microvascular disease of late life, and more standard T2 weighted imaging. All action-packed in a little over 30 minutes. Just to give you an idea of what can come out of this, tissue compartments can be defined on the basis of the T1 weighted imaging, allowing segmentation of individual brain structures. In this case, we see the deep gray nuclear structures and brainstem, as well as markers of, for example, gray matter in the cortex, an extremely sensitive index of progression of neurodegeneration. These measures, the shape and size of the brain turns out to be, if the measurements are done carefully enough, as they can be with this highly quantitative data, they are very sensitive to environmental, genetic, and lifestyle factors, as is illustrated here, and looking at changes highlighted in orange associated with differences in fitness. I promised you that the diffusion imaging tells us something about the wiring of the brain, and this is one of the real frontiers right now in understanding how the brain works. This is an example of a wiring diagram pulled out of a brain in the Human Connectome Project, which uses the same protocol. It allows us to understand human variation in terms of differences in this and the way in which it's manifest in behavior, and we also now are going to be able to take it into the realm of risk factors for late life disease. Resting state fMRI tells us about what the brain is doing when we're not thinking about thinking. It's always active. There are patterns of interaction between different brain areas, shown here, for example, in one specific kind of network in bright orange. What's exciting about this is this network probes a core set of brain regions involving the hippocampus, where memories are formed, and the precuneus, which is the brain's most active center. Both of these areas are involved in the progression of dementias, particularly Alzheimer's disease, and in work that has already been conducted that really needs to be extended and better understood. Genetic factors predisposing to late-life Alzheimer's disease actually affect the kinds of coupling that occur across this network even early in life. Well, three-dimensional carotid ultrasound imaging is also being included. This provides a very rich range of vascular phenotypes, including carotid intermedial wall thickness, wall volume, plaque volume at the carotids. Cardiac magnetic resonance is a hugely rich data set which allows imaging of structure and function of the heart by dynamically catching the heart pump action through a period of about 20 minutes, allowing really impressive maps both of structures of the brain. Here you see the structures of the heart. Here one sees the ventricular structures from which one can derive ejection fractions, wall thickness changes, acceleration maps of wall thickness change to really begin to understand cardiac dynamics. And to be able to do this on a large scale is simply unprecedented. Of course, we get some things thrown in because the large vessels, and particularly the aorta, are within the same field of view, and they are also dynamically changing, allowing distensibility and the dynamics of the aorta to be integrated with all of the other information we have on related to potential cardiovascular long-term risk. Moving down the body in the same set of 1.5 Tesla scanning evaluations, one can sample the abdomen roughly from above the liver just down to the tip of the pelvis. This allows a mapping of tissue distributions, and let me tell you, it has huge surprises. I asked the radiographers when I underwent a similar examination not to show me the results, just like a biobank participant, because I feared what might lie underneath. These are two individuals, both of whom have identical BMI, but despite their rather identical looking exteriors, what one sees here are really quite extraordinary variations in visceral fat between individuals, even with externally similar phenotypes. It really emphasizes how the precision of these imaging tools can help us take risk prediction to new sorts of levels. Now, the musculoskeletal system is critically important, and there has been, again, too little large-scale data. Dex Imaging has been put in place, allowing really a nice profile both of the major joints and the spine within the context of this data set. Now, the data management, I'm not going to have time to dwell on, but it is both a big challenge, but also just an extraordinary opportunity. What the objective is to, like the rest of the UK Biobank data, to make the raw images as well as derived measures available to the research community. Now, I think this is an opportunity for Biobank to begin to lead the way in really innovative approaches to management of this kind of science for the future. Not only do we hope that there will be ways of exporting data to researchers in more typical ways, say on hard drives, more exciting to me is the opportunity to begin to think about how this data could be opened up in a cloud-based resource resource so that it did not have to move, that clinical governance could be better maintained, and it would allow faster access by a wider group of people at much lower computational cost in order to do exciting things. Of course, the key issue throughout is going to be transformation of imaging data into biological information. The same kinds of rules will be applied to the imaging data as is applied to other resources, although thankfully this is not a depletable resource. As new analytical approaches are brought to it, it just goes richer by the year. One of the immediate challenges, however, is to ensure good quality control rapidly at source and thereafter through automated tools that are being put in place. Integrating this with state-of-the-art analysis so that certain parameters will be available to the epidemiology community very, very rapidly as the program progresses. Measures such as brain size, shape of major systems. We hope some parameters of cardiac function, certainly DEXA primary outputs, and some limited parameters from the 3D ultrasound. As time goes on, the academic community, which already is engaged in these problems, is going to help transform this data into further information that will become available. In all of this, we're being helped by, as I mentioned at the beginning, a global community, and the zeitgeist of the time is about transforming image data with great precision very quickly into data that is useful for understanding biomedical problems. The Human Connectome Project has been working with us very closely, and we're just at the right time as their project is reaching its maturity to be able to live off or start off the fruits of their labor over the last 5 years. Strategic awards such as that to the Oxford FimRib Centre from the Wellcome are further fueling this, and for cardiac studies, a real international effort to try to develop ways of capturing this extraordinarily complex, dynamic cardiac data as metrics from automated analyses. Now, all of Biobank has ethical challenges because of the richness of the data set and the potential for linkage across. The imaging data has some particular challenges, in part because of the richness and in part because of the salience of the data set. Major concerns, I think, that are somewhat generic are the risks of re-identification, genetic linkage, and so on. But what is of very special concern is because of the richness of the data, one can begin to, there is the potential for finding abnormalities that are unexpected that may have immediate consequences for health. Now, the approach of Biobank has been to work closely with the Ethics and Governance Council and others to try to find ethically firm foundations for approaching the problem in the future. And it's a particularly challenging one because the answers are not immediately obvious. One of the things that has been apparent for many years in the clinical diagnostic community is that imaging studies in healthy volunteers or asymptomatic volunteers or volunteers outside of a medical context are challenging because tools like MRI are grossly oversensitive to pathology. And in fact, in a Mayo series, one of the first to publish on this, the positive predictive value of something that was read by a radiologist as potentially abnormal in the context of normal human studies was only about 0.01. This clearly demands some special approaches. Data needs to come, we need much more data, but one of the larger studies, the Pomeranian SHIP study, really emphasized that in their scanning population of 2,500, roughly doing similar protocol, they found only between 0.1 and about 1% of each of the modalities had really potentially clinically actionable findings, despite a much higher incidence of abnormalities being found. Now, we don't have enough data at this point to make the correct balance between addressing research questions that are in the public interest and the individual welfare and autonomy of the participant. We have recognized how vital this kind of research is going to be, and I think one of the exciting short-term deliverables from this big project will be that the UK Biobank imaging pilot that is now off and running will, for the first time in a prospective and considered way, begin to provide the kind of evidence that's needed. Pragmatically, I don't have time to go through the details of the various mechanisms that are in place now. We can discuss those in questions afterwards. But pragmatically, our intention is to report some routine selected measures, such as blood pressure, bone density, and body fat, coming out of this visit from subjects, but to only feedback serious, unexpected findings of a very limited group that have been pre-identified as having potentially serious and actionable clinical consequences. Now, Biobank, the imaging enhancement, is already beginning to fuel other activities across the country, and this is what is really exciting. It plays right into the foundations of the UK Dementias platform being led by John Gallagher. Because of its unique characteristics and the potential for ancillary and recall investigations, rather special even amongst the many excellent cohorts that are across the country now. Well, it's been a whirlwind introduction, I'm sure, and it's the end of the day, but I do want to spend just a short amount of time saying once more what a privilege it has been to be part of this project and to contribute to UK Biobank, and how hugely impressed and how much I have been by all of my colleagues. But finally, I just want to emphasize how rich the range of my colleagues over these last 4 years have been. In addition to Rory and the strong team in Biobank, the Imaging Enhancement Working Group has been working consistently through this time, giving of their time from different universities across the country with no expectation of specific reward. It's been a huge pleasure working with John on the dementia platform. And there have been, by my count, more than 125 other consultants in the UK, Europe, and the US who have contributed generously of their time or given their own laboratory facilities in order to pre-pilot and develop some of the approaches. And finally, I have to close with immense thanks for the vision of the funders, without whom we wouldn't have such an exciting and positive story to tell. I hope you can all find something of real interest in this platform, and I look forward to seeing what we as a community can develop from it. Thank you.